I've got the drawings here, and what I've done is I've measured across here, which is the flange top where the cylinders sit. This bolt here fits into this hole here. There's this one here. So I know I'm in the right place there, and if I measure that distance across there on the drawings, which this one has proved, this is proved reasonably accurate, certainly to within a 1/16th, that is pretty much 8 1/2 inches. Now if I go to the casting and using similar dimension across there, there's 8 1/2 inches there. 8 1/2 inches comes to a tiny bit over the side here, which just is not right. There's something odd about it all. Yet if I go to measure this, let's see what this one says. It's not so easy, but that one is definitely 8 1/2 inches there. So that's 8 1/2 inches to the outside there, whereas that only comes to there. So there's a definite mismatch between the two castings. I would say that this casting is not matched to this cylinder. Now the only way I can see that we can get this to fit would be to mill a cavity, not a cavity, but to mill around here and make a metal insert, an aluminium insert that will slide into there, and I can bond it. I would have to leave it clear of that. I could bond it in position and then level it off, but that's the only way I can see if you want to use this casting. But then it will leave this, a large amount of, almost all of this metal exposed. It would look slightly strange. We can maybe do something about it, maybe blend that in. I don't know. It's entirely up to you what you want to do with it, but there's definitely a mismatch here somewhere. It's just really odd. And I've got no doubt about that. Pretty sure it's this casting that's. Well, here you can see the setup for getting the two bores parallel to the x-axis. These are two buttons that are the same diameter pushed into these holes. They're a good fit. There's a little bit of play, not much, and a nice parallel bar here. I'll run the timer along here and make sure that there's a 0 reading and move it about. This cylinder here is slightly longer than that one, so it's actually entered the hole that I bored in the plate, so I can swing everything around that ball until I get this parallel, and that's just finger tight to hold everything flat on the plate. Once it's nice and flat, I'll just nip that up and then I'll centre on this ball. Okay, well I've set the spindle directly over the centre of the ball, set my X and Y axes to 0, gone into conversational and told it to mill a pocket 67mm diameter. Now it might need opening out a little just to accommodate the cylinder, because I know that this cylinder here is bored slightly eccentric. For whatever reason, there's a few thou difference between the thickness at that side of the liner and that, but this is where it was bored, probably bored in situ, but the liners were put in obviously before it was bored, and it's been bored slightly off centre, or not necessarily off centre, but slightly over this way. As long as it's parallel to the crankshaft, vertical, parallel, who cares? It doesn't make any difference. So we'll take it from there. We'll put the cutter in, and there we see the second hole for the ball being machined, and it's looking pretty good so far. Quite happy with things the way they are. Great. Just opening this hole out a little, you can just see the, I don't know if I can focus on it, but you can see the depth of cut, 0.25mm on the diameter. just so that the ball can slide into there, or both balls can slide into this tension hole. I had to do the same with the other one, just very slight increase in diameter. So we'll see how it goes once. We're using a conversational program to square up this stock for a drilling jig for a motorcycle engine that I'm doing for somebody. Just using the Path Pilot, and there you see the program. Took a bit of getting the way I wanted it, but it's fine, and that will square everything up so I can use any face as a datum face when I go to mount the cylinders onto the top of the crankcase, so I can get them nicely aligned transversely across the engine. Here you see the cylinders. I've actually just had them clamped down with 2 bar clamps across here through T-nuts here. You see the T-nuts in the bottom there. I've been put the coordinates of these holes in, and there they are. So hopefully when I take this away, I should be able to get the conversational to do some spot drilling and drilling these holes through. Last time I tried it I just had no success with it, so there may be a bit of cursing and swearing goes on, but we'll see what happens. Well, here we are back again trying to drill these holes. There's the Path Pilot program. I should really load up the latest version, because there is a glitch in this program which refers to an R and a Z, and the R value being less than Z. So I went into the G code and I just changed the R value to greater than Z. I don't even know what the R value is meant to be, however it worked. So here we go, we'll cycle start this and we'll show you it in action. Here we go. I'm going to get some coolant on. Not that I need much for this at the moment. There we go. And there she goes. I've already just quickly tested it out to see if it's okay, and it seems to be fine. I'm just going to spot a hole there. There it goes, and you see the spot mark. Next, pretty much there. There we go. So the program, the drilling program allows you to spot first. You put in a spot drill, give it a number, and it works really well. You can't actually see the spots at the moment. They're definitely there though. I hope they are. I think that's one there, yeah. You can just see. That's looking good. I'm really pleased with things on this jig because it should work well. Here we go with that one. That one. And that one. And the last one there. Should tell me to put the next tool in, which I will do. I'm not using the tool changer. Okay. Here we are, drilling again. Just doing a peck cycle. I think I need to make it a little deeper than it is, but it's going okay. Yeah, it's a little bit high, but I can soon put those through again. I'll just move the drill down in the chuck a little before I do the next run of it. But it's working okay. The holes have actually gone right through. You can just about see on that one there the nip hole through, so I don't have to do anything else. That's good. Well, here we've got the setting jig finished. This hole here was the only hole, other than these 8, that I could actually centre on. If you look at the design of this, they had holes here, here and here, and I had to transfer these through, but unfortunately this flange here obscures the top of these holes, so I couldn't really centre on them, so I had to kind of draw down through there and transfer across. But I'm quite happy that they seem to be okay. When you sit on top, there's very little that'll stop the, you know, if I drill that and tap it, this will actually fit on top of the cylinder if I transfer those holes across. So that's the jig ready. I'll take that off there next, and next up will be to put the crankcases together and mount them on the milling table so that I can dress the surface flat. So that's the next big process. That's the first hole almost finished. Basically I'm just programming these, that's it finished, each hole individually, using this as my guide. This I made earlier. It's a fixture that allows me to spot drill through from here. It took quite a bit of making from a piece of steel. The setup on here is really quite awkward, to say the least. It's a big piece of machine, you know, this big chunk of metal. If I stand back, you can see how much room it takes on the mill, and we're almost at the maximum height we can work at. But there's enough room to drill the tapping size drill, which is all I need. The idea is I set this up, I set the engine up in here by running a parallel off here, and then taking my Heimer edge finder and running it along the edge till I got this set square, and I then put the Heimer on the top face, made sure it was set, let me just turn that off a second, made sure it was set running flat and parallel to the machine face. That took me about 2 or 3 hours to level everything off. It took, well, not 2 or 3 hours, but certainly well over an hour just to get it level both in that plane, in the X plane and the Y plane. And the reason that was difficult was because I haven't got the made a dummy shaft to fit in here. However, now that the bearings are fitted, that's more or less obsolete. And what I'm going to do next, well, what I did was I set this up on here once I got that flat, so it ran parallel along this face and along the X face. So that was the setup. Quite an elaborate setup really. I've clamped it here on the inside, about the only place I can find to clamp it safely. Drilled my first hole. I will then probably move on and drill the 4 outer holes, finish them, and drill and tap them so I can clamp this down, do the inner 4 holes, drill and tap them, and then go ahead and bore this out. Once I've just leave this plate as a guide, I can center on here and then do the rest of the machining, you know, from there. So that's and that will be real progress on this engine, because then the cylinder block will fit, and I'll be able to concentrate on getting on some of the myriad of holes that need drilling and tapping and opening out. But other than that, it's a nice bit of progress. There we are. Now you can see I've fitted a bolt in this hole here and tapped it while it was in the machine, and made a bolt to fit. Next thing, well, I'll run up this row of holes. I'll do this hole first, the end hole, because these end holes are all slightly deeper than the 4 inner holes. So it just means I can keep the same program. I've just got to set my 0 to the centre of that hole, and this one, and I could, if I wanted, in theory, go along and centre each hole. I might even do that, I might give it a try and see how successful I am with it. But sometimes I have problems finding centres. I don't know if it's inaccuracies in my tooling or me, but anyway, I know that that's on 0. I did that with the Heimer and it was spot on. Unfortunately, while setting it the Heimer, I did break a point and I've only got imperial probes on it, so sorry, 4mm probe. It was fitted, it's an imperial one, and it did have a 2mm probe, and they're so damned expensive. I don't think I'll bother replacing it, to be quite honest. They're about, by the time you import any into the country, they're about 50 quid a piece, so they're an expensive breakage, very expensive. With the one bolt in place, there's enough to hold the template on the top, or the fixture if you like. Centred all the holes, well, 4 outside holes. I've got the coordinates of the 4 inner 2. I've just set up a slight difference in depth. I think they're 3/4 inch deep here, whereas these are 1 inch and a 16. The reason they're deep is a couple of them have got locating dowels in them, so I'll sort that out at a later date. First priority, drill the holes, and then tap them, and then machine the balls. So there's the inner 4 holes about to be started. Looks okay. These 4 went okay, no problems with the way the program's running, so I'm quite happy. And when this is finished, I'm going to counterbore this hole and this hole to take locating dowels. Well, here we are, just starting to open out the bores in the top of the cylinder castings. I'm taking very light cuts because this is not a very rigid setup, and I don't want to upset everything. I did bring the tool down into the top of here and spent another hour resetting everything again, but it's not too bad. It's a very light cut, relatively anyway. It's an intermittent cut and it seems to be taking it okay. The program's working fine, so we'll just plod on with this and see how it looks when it's that one's bored, and then we'll move on to this one here. Well, we're now doing the second bore, as you can see. Actually, the castings here look in pretty good shape. There's not much in the way of blowholes. In fact, there aren't any. I haven't seen any in the mouth of the cylinder block. And also, both bores are pretty reasonably close to the jig that I made up. You know, there's not much eccentricity of the bores or off centre of the bores at all. In fact, I'm quite pleased with it. It should be a good fit when it's all assembled. So there we'll see, there's another cut. I've got 3 more cuts to do, and that should be this. I should be able to try the cylinder on the top. Hopefully it'll just drop in. I've given it about 5 thou clearance around the cylinder here, just to allow for any slight misalignment. There shouldn't be any, but it's always easier. You shouldn't have to beat the hell out of things to get them apart. But anyway, once the locating dowels are in, it'll be fixed in position properly. Well, there we go, the cylinder's on. With just enough luck, it clears this. I'm amazed that's as far along this way I can traverse the machine, and it just lets me put the cylinder block in. That's great. I'll drop in nicely. It's not going all the way down because there's a big lump of rag stuck under here. But basically it's fine, that looks good, and everything matches up here, so I'll be able to drill these holes through and sort this side out. So I'm really pleased with progress. Well, there we go, I've finished the counterboring of these 2 holes, this one here and this one here, and I've just tidied up the mouth of the cylinder casting, just to, it makes it easier for assembly. There was quite an excess of material in there. Why does that always come on when I'm talking? Anyway, that is all of this work finished on here for the time being. that's coming off, and a cylinder head for a car's going on next for some remedial work, but I'll continue with this. Okay, well, what I've got in the table of the machine, or on the table of the machine today, is this cylinder block, which is for a BSA Fury engine. It's been partially machined, and unfortunately the cylinder block that is to go with the engine that I've got, or the one that I'm building up and machining to go with this, had a different footprint on here. So the person who owns it has got quite a few bits and pieces of space, and he bought along another cylinder, which is this one here, which actually fits that profile. And unfortunately there's no liners in that, so I've got to bore this out to 4 thou less than that liner size and get the liner in. So what I'm going to do is, I've generated my own G-code program to run my vertex boring head, which I made an adapter for to fit in the machine. I like using this because it's a really nice, accurate piece of work. It's lovely to use, nice and easy to set, and you've got real control over the depth of cut and the size of the hole. And I've also figured out at long last how to use my bore gauges. I have a full set of these up to 8 inches in diameter from 1/2 inch. Beautifully made instrument, very expensive in their day. Mine came out of the Royal Aircraft Establishment, the RAE, made by a company called Matrix, which is, I believe, Coventry Gauge and Die Company, and very accurate. 2/10 of a thou is the division on here. Each one of those divisions there, the large divisions, is 1 thou. They've got a quite limited working range. What threw me was when you use these, I keep thinking like a micrometer, you open it out for the larger size. It's not, it's the opposite way. The larger this is, the further out those, further in the anvil pushes to push these out against the bore. So obviously you have to push this rod in rather than pull it out for measurement. So I've now got some idea of what I'm doing with it. So hopefully we'll be able to get good, accurate bore measurements with it. So we'll okay, well, there's the machine switched on. I haven't got any coolant on. I'll maybe put some on later as I get nearer the side. I just want to see if the program works okay. I've got my max valve cut down to virtually nothing. The idea behind the program is it's a simple G85 is the command. Basically it's a standard sort of boring program, in that the head will come down, the tool should stop just outside the bottom of the cylinder, and then come back up at feed rate and stop at the safe height. When it stops at the safe height, I can put a cut on and then press a button to run the program again. So that way I can just keep on doing that until I get the size that I want. So let's just slowly move on down. We'll go -2 inches, -1.4, looks like it's going okay. Feed rates are conservative, and there we are. That's it, just coming down to that's one of the stops out of the boring head. Never mind, at least it didn't do any harm. I've got the guard off here. There's not much to go wrong with this other than the head hitting that. Now there's a thing, will it clear that? 2.2 inches to go, yeah it will. Well, I was beginning to have doubts about whether everything was okay with this, because it's cutting only on this side at the top. However, I've just ran my DTI inside on my centre finder and run it round here, and it's to within half a thou of concentricity halfway down the bore, so I'm quite happy. I'm just going to... Well, I got a lot of chatter before, so I've cut the speed down. You can hear that. I'm not happy with that at all. I've sharpened the tool up. That seems a bit better now. At least it's showing signs of cutting properly. That's better. I wasn't very happy with it. So. Tremendous amount of chatter mark at the top. Just hope I can get... Well, there we go. It's just had another cut put on it. It's just touching at the top for whatever reason, I don't know. It's just at the very mouth, and then it's not all the way around either. It's maybe a little bit of bruising of the metal casting around the top there. But anyway. Well, there we are, still boring out this cylinder. I've cut the RPM down dramatically because I got a lot of chatter. I built up a real heavy chatter pattern, and the only way around it was just to cut the cut the RPM right back. That got the chatter under control, and I increased the feed by about a third by effectively, well, reducing the RPM, but also reducing the feed, but not quite as much, so relatively speaking it's taken a bigger cut. The cylinder itself must have been bored with a tremendous taper on it, because I've put a lot of cuts on, and it's still not all the way through clean to bottom. You can just hear the cutter starting to come up, and it's just taking a full bite now, and that's an inch off bottom. Well, not quite, about 3/4 of an inch from the bottom of that cylinder. So it was machined with a taper somehow. Well, I'm using the same program that I wrote up for doing the bore of the cylinder to do the counter bore in the top, and basically I'm going to keep this as a kind of wizard, because all I need to do in the G code is alter the start Z and end Z, and the rest of it's down to manual input at the head here. And I do tend to use the head quite a bit, so it's worth keeping as a program. So I mean, basically I'll just put another cut on here. 1, 2, seems like an awful lot, but it's quite a fine feed on that. So here we go, click the start button. A little bit of WD-40, the be all and end all for cutting aluminium or alloys. And you see it starts at a safe height of 1/4 of an inch. And there we are. And it stops at a safe height of 1/4 of an inch. Nice, simple. Took me less than a minute to change the data, and I was up and running with it. So it's really good, well worth having as a kind of thing for this, especially with the in and out passes. I find that you know, when you're using these as a boring bar, there's quite a lot of spring, even in this, which is quite a stout bar. There's definitely some spring there. Anyway, I'll get to and measure and finish this counter bore. And here we're still cutting the second bore. Not far to go before I get it full diameter all the way down. It really strange that the way it's been machined, the bore is actually oval by quite a few thou. Anyway, we carry on. Well, there's the other cylinder done. So that's both of these cylinders ready to have liners pressed in. I will probably do that the next session in the workshop. Now whether I can film it or not is a different story, because you've got to work quick. What I intend to do is to, on somebody's advice, put a wet sponge in there, cold sponge. I might even make up a little disc washer with some rubber on and a hole in the centre of it. Just one moment while I turn that off. I don't need it just now. Yeah, I might make a washer, large washer to go on the bottom that's still smaller than the OD of it, with a spigot on. Put a little seal on it and a bolt right through into another large washer with a vent on it and a piece of pipe, and I'll fill it up with water and cold water, so that at least it will stay cold. One of the problems you have with these being so thin, they conduct heat so rapidly, whereas if that's full of water, I think I daresn't freeze it because that would expand it, but nice cold water in there, as long as you've got a vent pipe, even if it heats up, it can vent itself out the top. So that's what I might try and get those in there quickly, but I'll see how it goes. They don't actually go in that way. Well, they do go in that way, as you see, but there's 4 thou of interference there, so that should be good enough once it's hot to shrink it in. We will see. I'll let you see the end results. Well, I'm not going to try filming the process, but here we are in the back of the workshop here, in the dirty end where I do my welding and hot work. The oven's on. I've got the cylinder block in the oven. It's showing 218, 219 degrees. It climbs up quite rapidly and drops off quite rapidly. Hopefully I'll keep an eye on it. I don't want to get much hotter than about 230 degrees, but it's climbing up fast. Yeah, what I've done here is I've made a plate to go over the bottom with a through bolt, one to go on the top. Plenty of waterproof washers top and bottom. Actually the top one's leaking, it leaks through here, so I'll just keep those plugs in loose, and hopefully the little bit of expansion that I expect to take place from the water warming up as it goes in will be taken up by the air gap underneath these 2 screws. There's very little in there, they're not even tight, so any slight expansion will just slowly seep out, won't do any harm. I don't want the cold water cooling the casting, I want the cold water to cool this liner, and hopefully that'll be the way to do it. If it's a success, it'll be great. If it's not, well, I'll just have to try and force it in, but usually that ends in tears, but we'll see. Well, there we go, the first one in, and it dropped in just beautifully, and you can see the water's expanding there now, so I better get the cloth. It's just behaving exactly as I thought it would. That cloth will stop the water going onto the job, but that's brilliant. I love that. I'm pleased with the way that worked. And as far as dimensions go, it was spot on. I expected it to drop in, and it did. It just took a little bit of finding the right sweet spot, and it fell in. Lovely. There we go, both liners in, still hot. The second liner, this one here, did not go in as easily as the first one. However, I had everything ready, plus it was the jacket, you know, I had it full of water, so it stayed cool, and it just required a little push with the press that I have, and it popped in. It's fine, and they're both down just below the top here. I think I'll probably have to take a bit off of here, but I'm not sure how much and so on. I haven't had a good study of the drawings. That might not need anything off, I just don't know, but it's looking good. I'm pleased with that.